Today, we want to do graphs of sinusoidal functions, but we're going to go backwards a little bit. I know we're gonna have to go backwards from what we've already talked about because I wasn't recording just a few minutes ago, but here we are again. Although it doesn't matter for the recording ground. So graphs of sinusoidal functions. The game we're going to play today is I'm going to draw part of a graph. Here's a part of a graph, and I'm just going to give you some information, and we're going to use that to figure out other points to get more information about the graph, and then use that information to write an equation. We're actually going to write a bunch of equations for this one graph. So the things that we need to know are where the middle of the graph is. That's going to be our plus D. We need to know the amplitude, the distance from the middle to the top and the distance from the middle to the bottom. That'll be our amplitude. That'll tell us the value that we're going to use for A. We need to figure out what the period is, the horizontal distance between two corresponding points. I've labeled the horizontal distance between two top points. And then the other parts, the horizontal shift, and whether we write plus or minus sine or plus or minus cosine will depend on what we choose as a starting point. I put start in quotes as usual because the graph goes on forever in both directions. But we got to pick one point to determine our horizontal shift, and that point will tell us whether we're going to be plus or minus sine or plus or minus cosine. The horizontal shift is the C, yes. So that'll tell us what we're going to use for C, and whether we write plus A or minus A, and whether we write sine or cosine. So from top to bottom, if we want to know the amplitude and where the middle is, we need to look at the vertical information. So the vertical information is the second coordinate, the 9 and the -3. The distance from the top to the bottom is 9 minus a -3. That's how we find distance. We take the ending point and we subtract the first one. So 9 minus a -3 is 12. But this is not the amplitude. How much amplitude is this? This is double the amplitude. This is 2 amplitudes. So what is the amplitude equal to? Now, 2 amplitudes is 12. So we'll cut it in half. The amplitude is 6. So that tells us what we're going to use for A. We're going to use plus or minus 6. The amplitude is 6. The midline is not necessarily going to be at 0. Because if the mid's at 0, then it's 9 to the top and only 3 down to the bottom. So that's not balanced. So the amplitude is 6. So we can go from the top down 6 to the middle. So we can use this to find the middle. We can either start at the 9 and subtract 6. So where does that tell us the middle is? 3. Or we can do the bottom, -3, and add 6. The middle will be 6 units up from the bottom. And this tells us the middle is at 3. If you get the middle from 2 different places, something has gone wrong. One of your calculations is incorrect. Yeah, if you to calculate the middle, we can either start at the top and subtract the amplitude to figure out where the middle is, or you can start at the bottom and add the amplitude to figure out where the middle is. If those two come out differently, something's gone wrong. One of them must be incorrect. But they came out the same. That's pretty good evidence that we got the right place. Also notice we can find the middle by just taking the average of the top and the bottom. 9 minus 3 is 6. 6 divided by 3 is the middle. So we can also do the or, different method entirely, average of the top and the bottom. a bad choice picking 6 because 9 minus 3 is 6, and the middle is at 3. Everything is 3 units apart. I should have picked an amplitude of 7. Oh. So the 6 that we got from the 9 minus 3 is 6 is not the same as the 6 that we got from the amplitude. That's just bad problem design on my part. So we've got our vertical information sorted out. I know where the middle is. The middle is at 3, and the amplitude is 6. So that gives us information that we're going to put into the equation. So this tells us that the absolute value of A is equal to 6, and the mid at 3 tells us that D is going to be a plus 3. The mid and the amplitude show up directly in the equation. Now we need to do some horizontal stuff. So we need to figure out the period, the distance from the top to the next top, or from the bottom to the next bottom. But we don't have that. We've got the distance from the top to the bottom. So that's not an entire period. So that's from the top to the bottom horizontally. Now we're working on horizontal stuff. Yeah. D is the vertical shift. Yes. So now we're going to start looking at things horizontally. And we're going to go from the top point to the bottom point horizontally. So we go from -2 and we end up at 8. So I do the same thing. I need to know that distance. It's 8 minus a -2, or 10. But the period is not 10 because we have not got back to the top. We've only gone from the top to the bottom. How much of a period is that? That's half of a period. So this 10 down here is only 1/2 of a period. See, one period goes all the way to the next top, but down here is only a 1/2 period. So we got to multiply by 2. So what's our period going to be? So now we've kind of got a lot more information. We figured out that the other top up here, vertically, this is going to be a 9. And the other bottom will have the same y coordinate. So vertically, we're going to be at -3. Now that we know that the period is equal to 20, we can use this to figure out from the top at -2 where the next top is. So if we're at -2, 9 at this first top here, where's this next top happen? 18, 20 units later. And if this bottom point here is at 8, where's the next bottom point going to show up? 28. It's just one period later. Yeah, we're looking at the x coordinates. We're looking at how far these 2 points are apart. So at this top, x is -2. At the bottom, x is 8. So the distance between those 2 points horizontally is 10. So the top to bottom is 8 minus a -2, or 10. But this is only half of the period because we've gone from top to bottom. We're only halfway through a cycle. So this is half of a period. So that means one whole period needs to be 20. Yeah. Yes, because the number that shows up in the equation is not the period itself. We called it B because, clever names for things. But B is not equal to the period. So we got to think about the number that we're going to be putting into the equation. We know that the period is 2 pi divided by B. And so that means that B is 2 pi divided by the period. So for this function, the number that's going to show up in the equation is 2 pi divided by 20. Which will simplify to pi over 10. The period is 20. That's the information about the function. The period is 20. The number that we're going to write into the equation is pi over 10. That will be the coefficient of x in our equation. Because the period is 2 pi divided by that number. So that number is 2 pi divided by the period, pi over 10 in this case. Now we've got lots of information. I just hit the thing that you might be copying. Copying it? All of a sudden it turns into Blair Witch Project. I couldn't watch Blair Witch Project, not because it was scary, because I get motion sickness really easily. And all the handheld camera work, I go, oh man. My friend was like, well, yeah, this is terrible. It's like, oh, no, I'm getting motion sickness. Ugh. Does anybody remember? No one was alive when that movie came out, were you? What year did it come out? There was yeah. 80, no, it was not 84. I was an adult. I think it's a 90s thing. Did you find it? Okay. Let's find our middle point. So we know that the middle points all are going to be at the same horizontal location. We found that out to be 3. So our mids at 3, that's going to be the y coordinate all the way across. Makes sense? They're all mids. We do have to figure out the x coordinate of these points. That would be 1/4, not of the x coordinate, but it would be 1/4 of that distance. So it's half the period from the top to the bottom, and the mid going down, that point, will be halfway. So that'll be 1/4 of the period. So between any two named points, we have 1/4 period. I didn't leave myself enough space. So 1/4 of the period. So now I'm gonna find the mids. So to find the other x coordinates, we're going to need 1/4 of the period. So 1/4 of 20 or 5. Those points are going to be 5 units apart. Sorry, I keep just like immediately running off the page, and it all fits. So those points are going to be 5 units apart. So if this top point is at -2, where's this middle going down? 3, 5 units later. -2 plus 5 is 3. 3 plus 5 is equal to 8. So that fits. We're on the right track. 8 plus 5 is 13. 8 and 5. 13 plus 5 is 18. So that tracks. 18 plus 5 more is 20 something, 23. 23 plus 5 is 28. If we go backwards, we go -2 minus 5. Where's this point at? -7. Now we should check to make sure that we're in the right locations. If I have this -7, that's at a mid going up. The next mid going up is at 13, 20 units later. Here's a 3 at a mid going down. The next mid going down is at 23. So everything seems to be tracking pretty well. It fits into our description. Not necessarily the page, but it fits the description. So just based on those 2 points and understanding how we know these points to be distributed, we can get all these other points. Any questions? We've also got 3 things that we can plug into our equation. I've got an amplitude of 6, a vertical shift of +3, and the coefficient of x is going to be pi/10. All we need to do now is figure out a horizontal shift, and whether you're using a plus or a minus sign or a plus or minus cosine, that depends on what point we choose to be our start. Where do we want to focus on? Yeah, our vertical shift is a +3. The vertical shift will always just be the mid. So to figure out what equation we want to write, we just got to pick a point to start at. We just got to pick one. So good news, we have a bunch of points to pick from. Bad news, we've got a bunch of points to pick from. We just have to pick one. Which one? 3, 3. 3, 3 it is. That's good. In case if we accidentally switch something, we won't miss. Good. I like that. That's good thinking. That's a big brain move right there. It's like, oh, these two are the same. I can't get them backwards. So that's cool. So what we want to do is we're thinking that we're going to start at 3. So we're going to choose a start. Remember, we always put start in quotes because it doesn't make any sense to say it starts there. But that's the one we're going to focus on. We're going to say this all points originate from here. So we have to pick one. So we'll choose 3, 3. So we need to classify what kind of point is 3, 3. Is it a top, a middle, or a bottom? It's a mid, and it's a mid going up or a mid going down. It's a mid going down. So it's a mid going down. Mid going down, nothing fits. Just make it a little, I could just zoom the camera out, but I have to move the entire camera up because it doesn't have zoom. And then it'll be at an angle and it'll piss me off. The mid going down, middle corresponds to sine, and down corresponds to negative. So we're going to be writing a negative sine function. And the x coordinate of this point will tell us what we use for c. Once we choose our starting point, that tells us 2 things, 3 things. The horizontal shift, where they're going to have plus or minus the amplitude, and whether we're going to use sine or cosine. So now we're ready to write our function. Y equals. Our amplitude is 6. So we're going to use this. I'm going to start by writing 6. That's going to be the coefficient of our trig function, which is going to be sine. But since we chose a point that's at the mid going down, it's going to be a negative 6 sine. Then we're going to make parentheses. Then we'll write the coefficient of x, which is b, which is pi over 10, times x minus. Then we write c, our horizontal shift. Then we close the horizontal shift, close the sine function, and write our vertical shift plus 3. Horizontal shift is 3, and our vertical shift is also 3. The horizontal shift will be the x coordinate of whatever point you chose to be your starting point. The x. We couldn't miss here because we have 3, 3, so. But for instruction purposes, we should say it's the x. Oh no. All right. Yes. I'd have had to draw it by hand. The thing that's always hard to see is where the mid is. So I'm going to write y equals 3. Oh, it even came out blue. Thank you. Thank you, Desmos, for reading my mind. Yes. Yes. Yes, you could. There are an infinite number of functions that we can describe that'll describe this graph. I accept all of them. So let's choose a different point that we take to be the middle of where we our starting point. Let's write this equation from the perspective of -2, 9. So let's choose our start at -2, 9. So -2, 9, we got to classify what kind of point this is. Where is this? How do we describe this point? So -2, 9 was way up here. So we would describe -2, 9 as a top. Top and bottom mean we're going to use cosine, and top means we're going to use positive cosine. For our horizontal shift, whatever the x coordinate is, that's c. C is -2. Now we're ready to write our equation. We've got all 4 parts. A, B, and C, just like A, B, and D, just like before. We have a new C. I'm going to start by writing A. That's the coefficient of my trig function. Since we chose as our point of view character at the top, it's going to be a plus cosine. We don't have to write plus cosine, but I like to emphasize things that are part of the decisions. Our coefficient of x which isn't the period, but told us the period, is pi over 10 x minus a negative 2. So it's going to be x plus 2. Close the horizontal shift, close the trig function, and write your middle plus d. This equation is trying to describe the same function. So let's type it in over on Desmos and see if it tells us the same function. I wrote plus d. It's because d rhymes with 3. And that starts with t, which rhymes with p. And that stands for pool. Let's go y equals positive 6 equals. There we go. A positive 6 times the cosine of pi over 10. To get pi and you're typing in Desmos, just type pi and then divide by 10. If we keep typing, we'll stay in the denominator. So I'm going to use the arrow to get out of that. Put parentheses x minus a negative 2, which is x plus 2. Close that, close that. The only thing we have left is plus the middle, and the graph sits right on top of the other graph. And here are our points. Oh, really? What if I turn this off? We can even use this to go find other points. There's the negative 7. So depending on what we choose to start, that will change what kind of function we write. Plus or minus sine, plus or minus cosine, and the horizontal shift. So that's kind of like the last piece of the puzzle. But we got to find those first 3. Those are always the same. So I could write this equation as y equals positive 6 times the sine of pi over 10 times pi over 10 times x minus c. Let's see. Keeps erasing my friggin' points. So I did a positive sign, so I'm at the mid going up, so I can choose negative 7. So x minus a negative 7. Plus 3. And there's the same graph. Because that is, I got to turn this one off. No, that one, this point. That negative 7, 3 is at a middle going up. So middle going up is positive sine. And the x coordinate there is negative 7. So it's x minus a negative 7. That looks weird. We wouldn't write it that way. We would actually just write plus 7. But that plus 7 means minus a minus 7. Any question? I don't know, okay. Everybody looks fine. You all look like this. It's too simple? Or it's too difficult? That's the only one I'm worried about. If it's too simple, it's just boring. And that's kind of like the default state in math. Yes. Plus 7, because remember our form is b parentheses x minus c. So we usually write plus 7 instead of writing minus a negative 7. If you think back to your algebra class, you had to do those weird things where it's like, I'll rewrite the subtraction as addition. And it's like, oh, 5 minus 2. And you had to write 5 plus a negative 2. And you're like, oh, why the F am I doing this? And this is why. It's how we shift things around. I don't think that's a good decision that we do that when you're children, because it doesn't make any sense. And we should be encouraging you to just kind of be more instinctive about things. And then later on, when you're trying to formally learn algebra, you can learn that subtraction is just addition of opposites. And that addition is just subtraction of opposites. But then you have to talk about things like the additive identity and additive inverses. And why would we want to do that? What is the additive identity? No, that's the commutative property. The additive identity is the number that you can add to anything and not have any effect. 0. 0 is the additive do-nothing number. What's the multiplicative identity? 1, because 1 is the do-nothing multiplication number. So that's what we call an identity. So. Yes. And inverses are what you do to get to the identity. So additive inverses are opposites, 5 and -5, because if you add those together, you end up at the additive identity. Multiplicative identities are reciprocals, because the reciprocal of 2/3 is 3/2, and if you multiply 2/3 and 3/2, you end up at the multiplicative identity, which is 1.
So we just put those are just different points.
Yeah, we pick one, and the point that we choose will determine what we put for our horizontal shift and what we put for the trig function and whether we have a plus or a minus on that trig function. So we could also write a negative cosine version of things. Y equals -6 cosine of pi/10. These are the ones that don't change. Times x minus, then I have to figure out one of the points where we're at the bottom. So like, a bottom point is 8 -3. So x minus 8, close that, add 3. And now I've got starting, that's what we're thinking of our starting. Since it's at the bottom, we have a negative cosine function. But all these functions are at the same graph. We have an infinite number of choices for what equation to write for that graph. Yes. And if I change this +3 out here to a -3, that shifts it all the way down there. It also freaks out a little bit when you get rid of that, because it's like everything's getting multiplied by 3. It's like, ah! Phew. It calms down. Any questions? Is that okay? Yes. Correct. Cosine is top and bottom. Positive top, negative bottom. That tracks, right? Sine is going to be the mids. There's a mid going up and a mid going down. Positive is mid going up. Negative is mid going down. So that tracks. I love how organized it all is. If only I could find something other than like start. Terrible. Even if I came up with a better word, I've been using start for so long, I don't think I could fix it. I thought focus might be a good point. That's your focus point. The anchor? Anchor, that's an awesome one. You come up with the best terminology for this class. To the point where when I write this all down and make a book, I'm going to have to give you credit. So. You'll get half of my profits from the book, which will be $0. But no liability. So if it costs me anything, I'll just charge myself. Any questions? Is that okay? All right, let's take a break until Tuesday. That's going to do it for today. That's going to do it for this week. Everybody have a good weekend.